Hello everyone, hope you all are well. So today we will discuss the chemical properties of haloalkanes and haloarenes. Let's begin with. Basically, the chemical properties are classified into three categories. Basically, it is in four categories. First one is nucleophilic substitution reaction. Second one is elimination reaction. Third one is reaction with metal. And fourth one is reduction. So, we will discuss one by one. Nucleophilic substitution involves two types of mechanism, SN1 and SN2 mechanism. Elimination is of two types, alpha and beta elimination. Now, first we begin with the nucleophilic substitution reaction. First, we have to understand what is nucleophile. There are two terms, nucleophile and electrophile. Basically, nucleophile is a species which is nucleus loving. If anything is nucleus loving, then it will stay far away from the electron. So, if nucleophile is nucleus loving, then it is electron hating. If it is electron hating, means it is electron rich. So, the species which are electron rich, that are nucleophiles. And the species which are electron deficient, which has lesser number of electrons, which are electron loving basically, that are electrophiles. For this, let us consider one example. If we have one rich person and another one is a poor guy, if we offer such amount of money to the rich person, he will not accept it because he has already a lot of money, so he will reject the money. Similarly, if we give electrons to the nucleophile, he will not accept easily because it is already electron rich. Now, if we offer some money to the poor guy, he will definitely try to accept. And similarly, this electrophile, as it is electron deficient, when we offer electrons to this electrophile, it will try to accept that electrons. So, these are nucleophiles and electrophiles. Now, here, nucleophile is electron rich species. Substitution means replacement. If in a reaction, nucleophile replace any other group, that reaction is called nucleophilic substitution reaction. Let us consider one example. Suppose this is an alkyl halide. If we take any nucleophile, H positive, OH negative. Here OH negative act as a nucleophile. This OH negative will attack on this carbon and this will go outside. What will happen? This R will combine with this nucleophile plus this will be removed along with it. The nucleophile will occupy the same position as occupied by the halide. So it is replaced the halide. So it is substitution reaction. This is the simplest substitution reaction. Now let us consider more examples of nucleophilic substitution reaction. These are the certain examples of nucleophilic substitution reaction. Let's begin with the first example. This is sodium sulfite. When alkyl halide react with sodium sulfite, what will happen? This sodium has positive charge and this is negative charge, -2. So this negative will attack on this alkyl group and this halogen will be removed. So it will form thioether. This thio word is used for this sulfur and this is ether. Next, if we use aqueous KOH, what will happen? This negative sign of OH will attack on this R group and it will move outside. It will form alcohol along with the evolution of potassium halide. Mechanism will remain same. Now, if we take sodium alkoxide, this will be the negative. This negative will attack on it and it will form ether. But make sure when we treat with sodium alkoxide, it will form unsymmetrical ether, and this process is called Williamson synthesis. Unsymmetrical ether means if there is methyl on one side and there should not be methyl, there will be ethyl, propyl, butyl, anything else. Means both the groups are not same. That is unsymmetrical ether. If both are same, then it is symmetrical ether. Now, for making the symmetrical ether, we will use silver oxide. Similarly, O2 negative, this 2 negative will attack on this alkyl halide and it will move outside. And it leads to the formation of symmetrical ether. Next, come to potassium cyanide. Replacement of this halogen by cyanide group. What will happen? Similarly, this Cn negative will attack on this alkyl group and halogen will be removed. In place of halogen, this cyano group will be attached. When this alkyl cyanide will be formed, it will undergo number of hydrolysis. If it react with water or concentrated HCl, then it leads to partial hydrolysis. Partial hydrolysis means it leads to the formation of amide. Now, if it is react with acidic condition, then it is H positive or H2O, and in the basic condition, it will react with OH negative and water, and it leads to the complete hydrolysis and form an acid. Next, if it treated with lithium aluminium hydride, nickel, in the presence of nickel, hydrogen is added, or in the presence of sodium ethanol, then it leads to reduction and it leads to the formation of amine. If this specific cyanide group will treated with sodium ethanol, then this reaction and addition of hydrogen will take place. Then this reaction is called Mendius reduction. Now, after this, now come to addition of silver cyanide. On adding silver cyanide, what will happen? It leads to the formation of isocyanide. Here, cyanide is formed and here is isocyanide formed. The difference is here is bonding with the carbon and here alkyl group is bonded with the nitrogen. This is sodium mercaptide. Addition of this group will lead to the formation of thioalcohol. Next is amine. If we add substituted amine, then it is called Hofmann ammonolysis. What will happen in that case? This lone pair will attack on this R group and halogen will get removed. And this H will be attached to this, H will be removed with this X and this NH2 group will be attached on the alkyl group. And it leads to the formation of amine. It may be primary, secondary or tertiary, which depends on the alkylated amine or without alkylated. Next is KNO2. This NO2 is a ambidentate group. This now reaction of alkyl halide with this KNO2. This is ambidentate. This NO2 is ambidentate nucleophile. What will happen? When it is used KNO2, it will react with alkyl halide and leads to the formation of a compound by bonding with the oxygen. But if it is treated with silver compound, then it forms bond with the nitrogen. Next, further reaction is with acid derivative. This is silver salt of acid. This negative will attack on alkyl halide and halogen will be removed and it will attach in place of halogen. These all are the examples of nucleophilic substitution reaction. Next is elimination reactions. Elimination basically means, eliminate certain group. if this halogen is present and hydrogen is present, this halogen is removed along with the abolition of this hydrogen. This is known as elimination, means remove any group. So it is of two types, alpha elimination and beta elimination. Alpha means if both groups are removed from one carbon, and beta elimination is if hydrogen is removed from the beta carbon. First we will discuss alpha elimination. For this halogen and this hydrogen is present on same carbon. This KOH act as a base. It will abstract this proton and this will move on this carbon. So this carbon will acquire negative charge. So to stabilize this negative charge, this Cl is a leaving group and it will leave it minus Cl negative, and then it leads to the formation of carbene. So this is alpha elimination, when both the groups are removed from single carbon. Beta elimination. In case of beta elimination, there is the one condition that there should be a beta hydrogen. This is carbon which is directly attached to halogen. So this is alpha carbon. Along with it there is the beta carbon. So on this beta carbon there must be the presence of at least one hydrogen. So if we consider this compound, if we talk about this compound, this carbon is alpha. Alpha has hydrogen but there is no need. This is alpha carbon and this is beta carbon. There is no directly attached hydrogen to the beta carbon. So it will not undergo beta elimination. Make sure you will not confuse with this CH3. After beta, this carbon will become gamma. So these hydrogens are gamma hydrogens, not beta hydrogens. So don't confuse with it. Now, what will happen? A base will come. It will abstract this hydrogen and this hydrogen will move on this and it will remove. Now what will happen? Single bond C. This bond will move here and it leads to the formation of alkene. Now it depends on which type of alkene will be favored. Now let us consider another example of beta elimination. Another example of beta elimination is CH3, C, CH, X, H2, H, H, CH, as we talk about this example, in this example, if this is the alpha carbon, these both are the beta carbons. Now it depends on the situation which product will be the major. So if we pursue with this path, that this base will abstract this proton and it will move here and this will get removed. This will be your A path. If we follow up A path, then what will be our product? CH3, C, double bond H, CH, CH3. This will be our major product. But if we proceed according to path B, what is the path B now? This is the base. This will abstract this hydrogen and it will move here and this will be removed. This is our path B. Now according to path B, what will be our product? According to path B, our product will be CH3, CH2, CH, double bond CH2. So now out of these, which product will be the major product? This product is major product. If we talk about subset rule, According to Sidzev rule, the more substituted alkene will be the major product, and according to Hoffman rule, the less substituted product will be the major. So this will consider as Hoffman product. So this will be considered as Sidzev product. So according to Sidzev, more substituted alkene will be the major product, but according to Hoffman, less substituted alkene will be the major product. This is about the elimination reaction mechanism. We call this elimination reaction as dehydrohalogenation also. Dehydrohalogenation. D means removal. Hydrogen means hydro means hydrogen. Halogenation means halogen. This means removal of hydrogen and halogen together. That is called dehydrohalogenation. Now we will discuss substitution versus elimination. First point, if we take alcoholic KOH, then elimination reaction will be favored. And if we take aqueous KOH, then it leads to the formation of product by substitution. By substitution. Second point, if we consider a bulky group on the base, if we take this as a nucleophile, this will not act as a nucleophile. This will act as a base. So if this acts as a base, then it leads to elimination reaction. Because it is a bulky group. Bulkier groups never become nucleophile. And this is not a bulky group. Along with oxygen there is a hydrogen. So it is not bulky. So this acts as a nucleophile. If it acts as a nucleophile and then it leads to the formation of product by substitution. This is substitution versus elimination. Now if we take alkyl halide, if we take primary or secondary alkyl halide, then it leads to the formation of product by substitution. And if we take tertiary alkyl halide, it will form elimination product because of its steric hindrance and bulkiness. That's all. Now we will discuss reaction with metals. Reaction with metals. Here is sodium, lithium, magnesium. With certain metals it can react. When any alkyl halide will react with sodium metal, then it leads to the formation of alkane along with the removal of sodium halide. This will form alkane plus 2NaX. This reaction is called Wood's reaction. This reaction is called Wood's reaction. Now, second, it will react with magnesium. When it reacts with magnesium metal in the presence of dry ether, it leads to the formation of a very important reagent, RMgX. This is called Grignard reagent. This will be used in various reactions. It is a very important reagent. Next is, it will react with lithium. It will form R negative Li positive. Next, when it reacts with zinc, it leads to the formation of R ZnX. These are the certain reactions with metals. Now we will discuss reduction. Last is reduction. In reduction, you can take lithium aluminium hydride as a reagent, tin with HCl as a reagent, nickel with H2, any type of reagent you can use, and it leads to the formation of RH. This is alkane. So these are all the chemical reactions of haloalkanes. In the next video, we will discuss the chemical properties of haloarenes. That's all for today. Thank you and have a nice day.